Hi, my name is Siti Nurhala Maisara binti Hasnadi and my matric number is 01DDT23F1001. So let's go to the question number 1. Aiman joined a programming competition in his faculty. He was given 1 week to solve a problem. Aiman asked for your help to construct a program to reverse the word that enter the program. For example, if user enter Ali, ALI, the output will display ILA, ILE to the screen. Aiman want you use stat to store the input. First, we need to integer main bracket curly bracket stop char stat semicolon string input semicolon. So for stat to hold character of the input word and string is to store the user input. Next, in the coding, I put enter a word and I will flip it for you. So when user enter a word, it push each character of the input word onto the stack. Each character is pushed one by one, stacking them on top of each other. This allows for reversing the order using last in, first out before. Lastly, while the stack is now empty, retrieve and print each other. Please remove character from the stack one at a time, reversing the order. So you can see the coding. I put char stack dot top bracket. So it's to get the top character of the stack. And below one char stack dot pop bracket, it remove the top character from the stack. Next to the output. So you can see in the coding when I run the program, it go to this enter a word and I flip for you. So I put mini project and it will flip my mini project, so it become TCEGORPINIM, and that's all.
Assalamualaikum and hi everyone. My name is Naim Malkis with IDP3. My matric number is 01DDT23F076. So today I am going to explain question number 2. Based on question number 2, we need to develop a food ordering system for XYZ restaurant using a FIFO first in first out approach. Each customer order are stored in a stack. Customers are organized in a queue linked list, with each node holding the stack of order for one customer. As cook prepare order, they pop item off the stack, display them on screen, and get them ready for delivery. So next slide, I am going to explain C++ program to simulate the process. So this is the coding using FIFO concept to handle customer order. So for box number 1 is to represent each customer waiting in line queue to have their food order process. For stack string order, this is a stack that holds all the food item the customer order. Think of a list of food item stacked on top each other. For node pointer next, this is the pointer that link to the next customer in line. This helps to keep track of the order which customer are waiting. Set next to now. This means there are no customer after this one initially, showing that they are the last one in line until a new customer are added. Second box of coding is how to manage. The coding is manage a queue of customer. So for node pointer friend is to the first customer in the queue. For node pointer real is to find the last customer in the queue. Queue for none, real none. To initialize boss pointer to now empty queue. So this slide to enqueue the coding, which is add a new customer and their order to the queue. So first we create a new node for a customer. Take order until the user type time. If the queue is empty, real equal to now. Both front and rear point to the new node. If not empty, link the new node at the end of queue and update user. Next is the DQ of coding system. Processes and display order for the customer at the front of the queue. Check if the queue is empty. Display and remove each order from the customer stack. Move the front pointer to the next customer. If the queue become empty, set real to none. Next slide is check if the queue has any customer. This coding helps to decide whether the process order or inform that there are no order. This coding is a simple check, yes or no. For this slide, the coding is a main function. The coding is provide a menu driver interface for user interaction, such as menu option is for place an order, process an order, and also exit the program. This coding has a loop. The loop is going to continue to prompt the user until they choose to exit. Next, the output of the coding. This output will display this order, which is customer add their food item to their stack and join the queue. Next is process order. The system take the first customer in line, prepare their order by popping from the stack and remove them from the queue. Third is and then they will be repeat continue until all order are processed. After that, This is showing that customer entering the queue, adding order, and having their order processed one by one by using the FIFO concept, first in, first out. So that's all from me. Next, I am going to pass to my friends.
Assalamualaikum and good day. My name is Nurnisa Safia binti Sabri and my metric number is 01DDT23F1159. My part, I will be explaining a question tree, which is we have to implement a binary search tree using a linked list, C++, and we have to create, insert item, delete item, and display data. Without further ado, let's start it. You must be wondering, what is BST? What is binary search tree? I will explain to you. So, binary search tree is an organizes data in a hierarchical manner. What is that? Okay, such as in this diagram here. We started with the root, which is this first person standing on the top is the root. And these are the parents, the branch. And these are the children and more children, leaves. Yeah, it represents as a tree. We start with the root and the branch and more branch and then leaves. So basically, it's like a family root or a tree root like that. I can give you a simple example such as that. All right. We're going to start with our first step, which is create BST, binary search tree. All right. To create binary search tree, we have to declare first the struct node. We have to declare the integer data, node pointer left, and node point to right. Wait, what is this? Data left and right. Okay. Data represent as integer value that will be inserted. And the left part is a left child node, and the right part is right child node. Okay. Here are the example of the coding to create a node. A function to create a new node. So a node point at the create node, which is we insert the value, integer value, and the node point at the new node equals to new node. New node, which is the integer value, and new node is the data and equals to value. New node is the left part child node and equals to new node, another new node, which is a right child node and equals to null pointer. Wait, quite confusing, right? Don't worry, we will see more and clear on the insert item data. Next, for the second part, which is insert the binary search tree. So, okay, let's say if I want to insert the value of 4, integer 4, it will check if the root is, if compare it with the null pointer, it will create a new node if 3 is empty. It will automatically create the new node, okay? Because we just started from the beginning, which is the root, okay? So, let's say next I will insert 2, integer of 2, value 2, okay? It will check for the second part, which is else if. It will insert in the left subtree. Why left? Because we have to compare it. 2 is less than 4, right? So 2 value of 2, integer of 2, less than the root, which is 4, it will goes to the left. Okay, can see that, right? Okay, let's say if I want to insert 6, it will check else if for the last part, which is insert in the right subtree. Right subtree. So for the right, we'll compare 6 is more than the root, which is 4. It will go to the right part. And the subtree, which is the binary search tree, will look like this. This is the root, and this is the left child node, and this is the right child node. Understand, right? For the next part, which is delete binary search tree. Let's say if I want to delete the value of 2. Okay, we will see the value of 2 is less than the root, which is the 4, and it's on the left child node, right? So you will check the value less than the root, and the coding will be root is the left part and equals to delete a node, and it will automatically delete the 2. Okay. For the next part, which is delete binary search tree. Let's say if I want to delete the value of 2. Okay. So if the child, if there's only one, so if there's only one child or no child, I will put it the coding. If there is more we want to add or insert more value or the item or the data, it will check for this part if the node with only one child or no child. And if there's more, node with two children and get the in order successor, which is the smallest in the right subtree. Next, step 4, in order display. So in order display for the coding is a function for in order traversal of the binary search tree. We want to see how the item that we insert will look like. They will place it in order. Let's say I insert 4 first, and then 2, and then 6. So it will automatically fix it in order, which is we started with the 2, 4, and 6. Next, step 4, in order display. So in order display for the coding is a function for in order traversal of. For the next part, which is step 5, the main function, where we have to see out for the user to enter or the item or the chosen or the choice that they want to use. Okay. These are the output here, the out. I put it as a binary search tree operation, and the first is insert, the second is delete, the third is display in order traversal, and the fourth is the exit. Exit from all of these choices that we want. So these are the output here, which is the first one, second, third, and fourth. And here we can enter our choice. All the choices here. For the next part of the main function, which is the enter value to insert. Okay. It will check if the root is empty. If the subtree is empty, it will automatically insert the item to become a root, a root value. Okay. And these are the insert output, which is if I choose, my choice is to insert, I will type 1, and then I will type in 2, which is the value of the root. Next, the second case, which is enter value to delete. Let's say if I enter the first item that I enter is this 2, the second, and the next item that I want to insert is 4. Okay. If I want to delete 4 in the subtree given, it will automatically check that it will delete the 4. What does it mean by if present? If there's 4 in what I inserted before, it will automatically delete. But if there's no 4, it won't change anything, or it won't change it. For the third case, which is in order traversal. In order traversal, they start with the root. Okay, let's say I insert the 2, 4, 6 just now, right? I insert 2, 4, 6, but 4 I already delete, and I want to see how many items are there. In order traversal, I choose the third choice, which is display, and in order traversal, they will give this in order, which is 2 and 6 for me. Last part, which is the case 4, is existing. Existing means like we want to exit from all of these choices after we've done with inserting the value or delete the value, the data, or after we see all the display in order traversal, we want to end the coding. Okay, we can use the fourth choice, which is exit. Okay, let's say if I accidentally type a wrong value, I mean the choice here, which is 6, right? There is no choice 6 in here in a binary search tree operation. There is no 6 operation. Let's say if I accidentally type in, and the default of this case, of this switch, then it will see out invalid choice, and please enter a valid option. Okay, that's all from me. Thank you.
Good morning to Tuan. My name is Chijoe 01DDT23F1077. Now I'm going to explain about question 4. The question is based on figure below. Illustrate the steps to find the target key of 52 by using linear search method. From here, we can know about we have to find the target key is 52. So from the first step, we have to find from the index 0. Because this is linear search method, so it is finding the target key sequentially. Start from index 0. We can see index 0 is equal to 8 and 8 is not equal to 52. So we will skip to the next index, which is index 1, until we find the targeted key, which is 52, is located at index 6. So from here we can know linear search is searching sequentially starting from index 0 until it finds the targeted key and it will stop the searching. So the conclusion is the target key of 52 is in index 6. After that, we will move on to the question B, which is using the binary search method to find the 52 target key. By using binary search method, we have to divide the list into half and find the middle element in the list. So from the first step, we can see our middle element is 34, which is in index 4. After that, we have found out that 34 is less than 52, so we will look at the right half sublist. So from the right half sublist, we have to find the middle element of the right sublist. So here we define the middle element of the right sublist is 55, which is located in index 7. After that, we have seen that in index 7, 55 is more than 52. So we have to focus on the left half sublist of it. So after all, we can see that we have only left 2 elements in the left half sublist. After that, we have to define the middle element in the left sublist. So now we can define the middle element in index 6 and also the last element in index 6. So here we can see in index 6, the element is 52. So from here, we can know the conclusion of the target key of 52 is in index 6. So from the binary search method is from a large list and divide it into half and find the middle list. After all, divide it again into half to search for the middle element and compare with the targeted key to make a comparison to define whether the targeted key is located at the left or right half sublist. That's all from our presentation. Thank you.